Here I have an AND gate, and both its inputs, x and y, have been negated. So we would term this, or define this, as not x ANDed with not y. This is an OR gate. It has two inputs, x and y. Its output has been NOTed. So we would define this as x or y NOT. These two are equal. Really? How do you know? Well, we really don't. So what we'll do is we'll truth table this one first, and then compare with this one, with this truth table. So let's start with this guy. Here I have my xy component. Here's my not x, not y component. And this is my not x ANDed with not y. So let's start putting in the numbers. 0, 0 is my xy input. I negate both of them. It becomes 1, 1. I now AND these two together. 1 and a 1 is a 1. Next line is 0, 1. I NOT these two, negate these two, and it becomes 1, 0. If you AND a 1 and a 0 together, you get a 0. The next input is 1, 0. I NOT these two together, negate them, and that becomes a 0 and a 1. AND these two together, and you get a 0. Next, I have a 1 and a 1. I negate these two, or NOT these two, and I get a 0, 0. If you AND two zeros together, you always get a 0. So, there we go. Not x ANDed with not y gives us 1, 0, 0, 0. That's our defining output. We'll truth table this next. Here's our NOT gate, and it's inverted here, giving us not x or y. OR gate, not x or y. So here's our xy component. Here they get ORed, and at that point they have been negated, giving us not x or y. So let's begin our input. 0, 0. OR these two together and you get a 0. Negate that and you get a 1. Go to the next input. 0, 1. OR these two together and you get a 1. Negate the 1 and you get a 0. Next input is a 1 and a 0. OR them together. You get a 1. Negate that. You'll get a 0. Next input, we have a 1 and a 1. OR those together and you get a 1. Negate that 1 and you get a 0. Let's put these two side by side. And they are clearly equal. These two are clearly equal. So, this gate and its output equals this gate and its output.